Hello, thank you for joining us all today. I'm Melinda Walder, Managing Editor of Spudman Magazine. I'd like to welcome to today's webinar, Sustainable Potatoes, Why Your Fertility Choices Matter, which is brought to you by ICL. Our guests today are Dr. Jason Haegele, ICL's North American Agronomy Lead, and Georg Lemperg, ICL's Global Food Market Relations Manager. This webinar is eligible for 1 CEU credit, and after the presentation, there will be a QR code where you can sign in and receive that credit. Today, we will talk about what sustainability really means for potato producers and how fertility choices directly impact environmental sustainability and profitability from farm to table. If you have any questions throughout the webinar, feel free to ask them in the Q&A section at the bottom of your screen. We'll get to as many of them as we can. Now, I would like to welcome our guests, Jason and Georg. Welcome, and thank you for presenting today.
Thank you, Melinda, and good afternoon to everyone. It's a pleasure to be back with Spudman again, representing ICL, and also a special thanks to my colleague, Georg, who's joining from Germany, so it's quite late in the day there, and I really appreciate his time and the sharing of the expertise that he'll provide as we talk through the slides today. So as I mentioned, we've been with Spudman for this will be the third webinar over the last year or so. And so some of the themes, if you've participated in those previous webinars, will seem familiar. We talked about a year ago about the importance of secondary macronutrients, specifically calcium, sulfur, and magnesium for potato production, potato yield, and potato quality. We've also talked about the importance of phosphorus management for optimizing potato yield and quality as well. So today we'll start to tie some of those same themes together and really unite around this topic of sustainable potatoes. What does that mean, and why do your fertility choices matter? So I'm with the North American team as the agronomy lead, and having a background in agronomy. And then Georg works with us on our sustainability side. Georg's background is in the food industry, trying to tie together the activities of an input manufacturer like ICL with some of the current focus on sustainability and quality within the food industry. And so with that, I'd like to welcome Georg and ask him to open our webinar today with a background on why sustainability is important. Is it necessary, and how can we turn this into an advantage? So,
thank you, Jason, and good afternoon to everybody. Yeah, so I will be mostly covering the introduction today, and we really thought would be important to bring in the perspective of the food industry a little bit, because in many cases, of course, it's the demand of the food businesses that will be an important driver of sustainable changes to plant nutrition programs. And so we thought this would be a good way to kind of round up today's webinar. Jason, can you move to the next slide, please? Thank you. So I wanted to start off from kind of a 30,000-foot perspective and wanted to introduce our overall sustainability challenge. So really kind of at a human level, if you will, with the planetary boundaries model from the Stockholm Resilience Center, because it aims to consider the global view and not just climate, for example. Now, we don't have time to dive into this in detail today, but in some way, all 6 boundaries that you see in front of you right now that are surpassed according to this assessment relate to agriculture. And I wanted to briefly touch on 3 examples to broadly illustrate how. So for example, there's freshwater use, and of course, agriculture is one of the biggest users of freshwater. Then there's also land systems change, which, for example, relates especially to changing tropical forest or agricultural land. And lastly, the boundary of biogeochemical flows looks at the sustained flow globally of P&N. And of course, that relates fairly directly to agriculture as well. Now, to be very clear, this is not meant to blame farmers for our global environmental challenges, not at all, but it is meant to explain at the highest level why many food businesses feel the need to start making changes to their supply chains to preserve our planet at a time when the global population is also continuing to grow. Jason, can you move to the next slide? Can you click twice more? Thank you. All right. Yeah. So, but it's not all bad news. On the plus side, many consumers are also aware of the challenges that we're facing. And so, of course, with some skill, if you know consumers have awareness of something, that can be turned into an economic opportunity. And of course, it's also important because any type of agricultural transition will not come free. So additional money needs to be generated somewhere, and consumers are, of course, an important part of that equation. So to begin with, here are a couple of statistics about consumer expectations about food sustainability. So 79% of consumers say companies should protect the environment. 53% of consumers are concerned about the green premium today, so overpaying for sustainable products. But that's down from 70% in 2011. So even kind of on the negative end, if you will, there's still a movement towards sustainability. And then lastly, 1/3 of US consumers consider the environment when purchasing products all or most of the time. So these are folks that are extremely focused on environmental choices when buying products. Now, of course, something that will most likely have come to your mind now is to say, well, it's great that people expect this, but it doesn't necessarily mean they're willing to pay for it. And to that end, Nielsen and McKinsey came out with a study just last year that actually looks at that problem more specifically. Next slide, please. Okay, so what Nielsen and McKinsey looked at in this study, and we're comparing, but basically products with a sustainability claim and products without a sustainability claim. And so if you look at the first 2 points, so the 8% additional growth over a 5-year period, or the compound annual growth rate advantage of 1.7% per year, that's basically the same number. What these mean is that basically products with a sustainability claim will outgrow products that don't have one at that rate. Now, you might think, okay, that's not a huge number, you know, around 2% a year, that's not terribly big. But for most consumer packaged goods, these are extremely saturated markets. For example, if you're thinking about like the cereal shelves in your local supermarket or so, not a lot of overall growth of that segment happening necessarily anymore. And so basically, if you're growing 8% additionally over that period, that comes at your competitor's disadvantage. And so taking away market share is extremely important to those types of businesses. And that's really kind of where a huge advantage for them lies. And then on top of that, of course, the more specific the claim, the higher the associated growth rate. So again, you can outperform that additional 8%. And the more claims, the better. So if you have more very specific claims, so to say, not just saying, I don't know, sustainably sourced, which doesn't really mean anything, but, you know, being able to talk about, for example, your own regenerative agriculture program or having certifications in place or so, that again helps you outperform that number. And so ultimately consumers will end up paying you more for more sustainable products. Next slide, please, Jason. Okay, so now that we know that there is a problem to be solved around sustainability, and we also know that there's economic opportunity related to kind of helping solve that problem, of course, the next logical step is that, you know, food companies are going to move in that direction. And so on the upcoming slides, I want to outline briefly about how food businesses often choose to communicate these changes to consumers, and then how they actually put this into action to make changes towards more sustainable agriculture. Next slide, please, Jason. And click twice. Sweet, thank you. Okay, so when I was thinking about how to explain why food businesses predominantly focus their outward communication to consumers only on one aspect of the agricultural changes that are possible, I thought it was easier to show rather than to tell. And as you may have already guessed, which change that I'm talking about that they often use in the outward communication, it's regenerative agriculture. And so basically the picture that you see on the left was just a Google search for regenerative agriculture. And the picture you see on the right is a picture that was a Google search for precision agriculture. And what this is meant to highlight is basically, if you look at the picture of the left, you know, it's like very green, flowers, you know, the farmer doesn't have to wear any protective gear or anything like that. So for folks that necessarily don't know a lot about agriculture, this comes to mind when they were to say like, oh, draw us a picture about what natural settings would look like for your food. And the picture on your right, which of course is also something that's very important in the context of sustainable agriculture. So for example, in this case, variable rate application is, like I said, very important, but extremely difficult to explain to a consumer on the back of a cereal package, or maybe in a short post on Instagram or so. And so that's why usually food companies will focus more on that natural regenerative agriculture side in the outward communication, because it's just more easily aligned with what consumers would expect. Next slide, please, Jason. Okay, however, if you want to look at how food businesses are actually looking to put sustainability into action, I think the most comprehensive current example is the Regenerating Together framework from the Sustainable Agriculture Initiative, SAI. So what you see on the slide is an excerpt of the outcomes that they're looking for within that framework. And what is important to know about the SAI's membership is that it's basically a who's who of the world's biggest food brands, including McCain, Pepsi, Kellanova, Mars, ADM, Cargill. You get the idea. And so one of the most persistent criticisms of regenerative agriculture, and I think absolutely deservedly, has been that there hasn't really been a clear definition of what regenerative agriculture means. And so this framework is a first step towards addressing that. And eventually it's going to be turned into a certification. Two other things that I want to point out. So the three circles that you see are all around outcomes that relate directly back to the planetary boundaries that I mentioned at the beginning of what I was just talking about. So water use, land change, and nitrogen use. And the other is that, of course, this document is not so focused on outward communication. And here it naturally does include, of course, outcomes that can be achieved with precision agriculture, for example, nitrogen use. And so that will conclude my introduction for today. And I'm going to hand over to Jason, who will tell you a little bit about how our products and, of course, your fertility choices can hopefully support you in achieving some of the outcomes that you see in front of you right now. Jason, back to you.
Thank you, George. Thanks for that background and introduction. And so as we make this transition and think about this question of fertility choices matter, as you've interacted with food companies and you have a greater understanding of how food companies are increasingly active in sourcing their input products, vegetables, fruits, cereals, etc. How active are these food companies in researching agronomic decisions related to fertilizer use, or maybe in some cases dictating or suggesting fertilizer programs or crop nutrition programs for the materials that they're sourcing for their products?
Yeah, sorry.
No, go ahead, George.
Yeah, no, I think all of these factors are extremely important. And as you're well aware, we've been engaging quite closely with the food industry over the last few months to talk about and really try to support them in making the transition towards more sustainable agriculture. And this has been a wonderful journey and very successful.
Thank you. So as I pointed out at the beginning of the presentation, in past Spudman webinars, we've talked about polysulphate, we've talked about phosphorus management. Those will be two of the three case studies that we'll highlight today. We'll also talk about controlled release fertilizers for nitrogen specifically. So there's a theme here of managing nitrogen, managing phosphorus, managing fertility in general, and certainly the impact that fertility management and fertilizer choices can have on water quality, as well as other environmental metrics like air quality. So the first case study I want to highlight is the use of low carbon footprint fertilizers to increase yield and nutrient efficiency of the overall production system. You can think about this as nutrient use efficiency of potato production specifically, but also more broadly of nutrient use efficiency in the crop rotation over multiple years. So the example that we want to highlight is ICL's product called Polysulphate, which is a natural mineral-based fertilizer. The mineral itself is called polyhalite. Polysulphate is a product name, but this is certainly a naturally occurring mineral that contains 4 essential plant nutrients: sulfur, potassium, calcium, and magnesium. And these are all these mineral elements. The potassium, the magnesium, and calcium are all sulfate-based or sulfate-based form, so that they're readily available for plant uptake, but also available over a gradual sustained release profile during the season, which makes the product very efficient and improves the efficiency of the crop response to key nutrients like sulfur. Polyhalite's been found several places around the world, but there's currently one mine in operation producing polyhalite commercially, and that's ICL's mine at Bolby in England. And so the picture on the left side of the slide is our mine there. The water in the background is the North Sea, and then this mine is about 4,000 feet deep and then extending out underneath the North Sea to collect this mineral polyhalite. And so as we think about this conversation of just sustainability and some of the fertilizer choices that can impact sustainability, polyhalite is an ideal fertilizer choice because there's no chemical processing involved, which reduces cost potentially, but also reduces the environmental impact compared to other commonly used fertilizer sources like potash, phosphates, and nitrogen. And we'll talk more about that here in a moment. So from an agronomic perspective, this product is unique in that it releases nutrients. Sulfate is one example over a long, gradual period of time during the growing season. And so as we look at this graph on the right side of the picture, we have different sulfur sources: ammonium sulfate, potassium sulfate, kieserite, which would be magnesium sulfate, and then the yellow curve would be polysulphate. And the point behind this data in this graph is that sulfur release from polysulphate extends over a long period of time during the growing season. And from a practical perspective, that means that this sulfur is releasing exactly as the crop needs it, or more in line as the potato crop needs it, so that there's less opportunity for loss of sulfur, loss of sulfate from soils, particularly coarse textured soils that are prone to nutrient leaching. And because of that gradual release of nutrients over time, we're providing the crop, potatoes in this example, more opportunity to capture that nutrient and turn it into a harvestable product in the form of a potato. So as we think about more broad global market trends related to agriculture and related to food, polysulphate really fits nicely with many of those trends. We talked a little bit about the nutrient use efficiency and how we can improve that with a gradual sustained release of nutrients over time, balancing N, P, and K nutrition with important secondary macronutrients like calcium, sulfur, and magnesium. Environmental aspects of being fully natural, natural mineral, a low carbon footprint in its production, and then reduced potential for leaching from easily lost nutrients like sulfate. Because polyhalite is a naturally occurring mineral with very little processing that is involved other than crushing and screening, it's organic approved. And then also with the secondary macronutrients, calcium, being one key example, polysulphate increases food quality, particularly for fruits and vegetables like potatoes that are very responsive and dependent on calcium for not only yield but also key quality parameters. Okay. So fertilizers, certainly have an impact on carbon emissions, and that can come, from different sources. It can, come from the energy involved in, processing fertilizers, manufacturing fertilizers, and in the case of nitrogen-containing fertilizers, there's certainly an impact, due to the natural gas and inputs that are involved in manufacturing those nitrogen-containing fertilizers. As we compare polysulphate, to other, commonly available fertilizer sources on the right side of the slide, we see that there's a broad range of estimated carbon footprint at the manufacturing plant gate. So in other words, as these fertilizers are leaving wherever they're being produced, this is the estimated carbon footprint of these different products. At the bottom of the graph, we have nitrogen-containing fertilizers like calcium ammonium nitrate, urea ammonium nitrate, all fertilizer sources that you'll recognize, and those tend to have very large, relatively speaking, carbon footprints due to the energy involved in producing those products compared to more mineral-based fertilizers like potash or potassium chloride, potassium sulfate, and polysulphate, which are down at the lower end of the scale. And what makes polysulphate superior to all of these fertilizer sources is that 100% of the material that's extracted from the ground and brought to the surface through the mining process can be potentially used as a fertilizer without any waste involved in the process. Thinking about potatoes specifically, potatoes are one of the most intensively researched crops that we've looked at for polysulphate trials in North America, and these are just a few examples of trials that have occurred in recent years from 2018 to 2021. There have certainly been other trials that have occurred since then, But as you look at this range of trials across important potato growing regions of the United States and Canada, we have relatively large increases in either total yield or marketable yield that have occurred from using polysulfate as a source of secondary macronutrients like calcium, sulfur, and magnesium, along with the potassium that's also contained in polysulfate as well. And so this is one thing that we've talked about previously, but the other point that I want to bring out in this is that when we supply a nutrient, a key, often limiting nutrient like sulfur, we can improve the efficiency of other nutrients as well, nitrogen specifically as one example. The nitrogen sulfur ratio is commonly recognized as one indicator of nitrogen use efficiency. And if we have limiting sulfur, which is common in potato production, but many cropping systems, we may not be getting the full value of that nitrogen, or nitrogen use efficiency may be low, simply because we have a limitation in another nutrient that's important for nitrogen assimilation in the plant. And the other key factor to point out here is that one way in which nitrogen use defined is simply yield per unit of nitrogen fertilizer applied. And so with that definition, any increase in yield without increasing the application of nitrogen is in effect an increase in nitrogen use efficiency. And so you think about an increase in yield that comes from something like a fungicide application, that can increase nitrogen use efficiency, assuming no additional nitrogen was applied. And in this example, by addressing a key limitation in sulfur, or improving the availability of sulfur through a product like polysulfate, we can increase yield and in turn make the use of other nutrients like nitrogen more efficient. And so here's an example of this. This is a trial from North Carolina from a couple of years ago, where we had two different varieties. We had a grower standard practice, which included gypsum. So it wasn't necessarily limiting in sulfur, but you did have calcium and sulfur applied as gypsum, along with the grower standard nitrogen and potassium program. And then compared to the grower standard practice, we had polysulfate at either 360 pounds per acre or 720 pounds per acre, replacing the gypsum in that grower standard program. All of these treatments would have had 300 pounds of nitrogen per acre applied throughout the total nutrition program. So the first thing that we can look at is the yield increase, and at the highest rates of polysulfate, we had increases in total yield, but also yield of the number 1 grade potatoes. But more importantly, in this conversation about nitrogen use efficiency, if we calculate the nitrogen use efficiency as the pounds of potatoes of total yield, divided by the nitrogen input, or 300 pounds of nitrogen per acre, we see that nitrogen use efficiency, or the amount of potatoes that we produce per pound of nitrogen applied, increases significantly, at least in the case of the Snowden variety, just by addressing other nutrient limitations with the application of a product like polysulfate. Okay. So going back to the concepts that George introduced earlier, by using or choosing a specific fertilizer source like polysulfate, which has a low carbon footprint compared to other fertilizer sources, we can also affect not only overall nutrient management, but we can also specifically affect nitrogen use of the crop by impacting that nitrogen to sulfur ratio, the balance of nitrogen to sulfur, and ultimately nitrogen use efficiency of the cropping system. All right. The theme of managing nitrogen more effectively, or improving the efficiency of nitrogen, controlled release fertilizers are another tool that's available as a way to reduce nitrogen losses to the environment, and in doing so increase efficiency of nutrient use or nitrogen use. So I think many have a concept of controlled release fertilizers and what these might be. Generally, controlled release fertilizers are thought of as urea or other nutrients that are somehow coated with polymer or a resin coating. But the specific definition of a controlled release fertilizer is a nutrient with release patterns controlled and a prescribed or standardized release rate and release time at a specified temperature. And so, thinking about controlled release fertilizer products that are available in the marketplace, you'll often see these as having different longevities, 1 to 2 months, 2 to 3 months, 3 to 4 months, etc. And that longevity or that release time is measured at a specific temperature, which can be 70 degrees Fahrenheit, or depending on the manufacturer, can be other temperatures as well. And so these products are formulated and they're designed, or you can intentionally select these products to meet the nutrient release or nutrient uptake requirements of a specific crop like potatoes, or choose products based on environmental conditions and soil moisture regimes as well. So why control release fertilizers? Control release fertilizers, or CRFs, are very effective at synchronizing nutrient availability with the crop demand or the crop need. As we think about the 4R nutrient strategy, the right rate can, in theory, be achieved with all fertilizer sources, but achieving the right timing, can be achieved through different methods, including split applications, whether that's top dressing, in season, fertigation applications, or using a good quality CRF product to manage that release of nutrients over a specific length of time during the growing season, to try to match up the supply of those nutrients to the demand that the crop is expected to have for those specific nutrients. Control release fertilizers, again, are often polymer coatings or resin coatings. And the idea behind these different coating technologies is that they're semi-permeable, so they allow water into the granule, they allow nutrients out of the granule, but the exact composition of the coating as well as the thickness of the coating are what dictate the release rate in the field due to environmental factors, moisture and temperature as well. And so as we look at the picture on the right side of the slide, the idea is that these granules are applied to the soil, either incorporated into the soil or on the soil surface. Water and soil moisture will start to move into the granule. The inside, the nutrients, whether it's urea or some other nutrient source like potash, will start to solubilize within the granule inside the coating, and then over time, those nutrients will diffuse back out through the coating in response to those environmental conditions like temperature. Higher temperatures cause greater release of nutrients over the longevity or lifetime of the product that's being applied. So with that controlled release of nitrogen over time, the goal is to reduce the amount of nitrogen lost from the cropping system. And so as we look at the graph on the top left, we have an example of urea at a 1x rate, urea at a 2x rate, and measuring the total amount of nitrogen lost relative to the amount of nitrogen applied. So with a 1x rate of urea, we have a little over 40% of the nitrogen loss in this particular test or experiment. Closer to 50% with a 2x rate. But when we then take that same amount of nitrogen or urea in the 1x rate and coat it or apply it as a control release fertilizer, we reduce that total amount of nitrogen loss to somewhere around 15% compared to 40 to 50% for the uncoated urea. And then with that reduction in nitrogen loss, of course, we have an increase in nitrogen use efficiency, or more yield generated per unit of nitrogen applied. So if we have less nitrogen being applied or lost from the system, there's more opportunity for that nitrogen to be captured by the crop and turned into a harvestable product. And that nitrogen loss can occur in different ways. It can occur due to leaching in a high rainfall, high irrigation, coarse textured soil type of environment. It can occur due to ammonia volatilization of the urea soon after application. Or it can potentially occur due to denitrification over time in the soil as well. So by managing that nitrogen application with a controlled release fertilizer or a coated product, we have the opportunity to reduce all of those paths for nitrogen loss. So here's a real world in the field example of this. And this was a trial that was conducted in Michigan in 2016. In the graph on the left, we have the potato yield for chipping potato of A grade potatoes expressed as hundredweight per acre. The gray bars, we have a grower standard practice. So this would be uncoated nitrogen and potassium sources at 100% of nitrogen, 100% potassium, reduced nitrogen or reduced potassium inputs. Although there were some slight differences, the yields between these three treatments were not statistically different. They were in essence the same. And then the two bars on the right were ICL's Agrocote max-based product, or a polymer coated urea. We also have a coated potassium as well at a couple of different rates. So 100% nitrogen, 100% potassium for the fourth treatment, and then a somewhat reduced input of nitrogen and potassium, 75% for each of those in the fifth treatment. And so the point here is that with these coated products, either at the full grower standard rate of nutrient input or the reduced rate of nutrient input, we had an increase in yield over all of the grower standard practice sources of nitrogen and potassium. We calculate the nitrogen fertilizer use efficiency, or the pounds of potatoes per pounds of nitrogen applied. We see that we have NUE values ranging from 126 pounds of potatoes, all the way up to 210 pounds of potatoes per pounds of nitrogen applied for that last treatment. And the point here is that with controlled release fertilizers, particularly controlled release fertilizers also applied at a lower rate of nitrogen compared to what would be typical for the grower standard practice, we have the opportunity to again reduce nitrogen loss in the field and also improve nitrogen use efficiency. And so when we think about fertilizer coatings, controlled release fertilizer, particularly controlled release fertilizer applied to urea, we have the opportunity to affect the climate and agricultural sustainability through improved nitrogen use. All right. So the last section is transitioning from nitrogen, but now focusing on phosphorus. And all of us in agriculture will understand that phosphorus is often scrutinized as a contributor to lower water quality. Specifically thinking about algal blooms and the hypoxic zone in the Gulf of Mexico. And as an example of that, much of North America, or at least the United States, is drained through the Mississippi River watershed that includes many different states spread out across many different agricultural regions of the United States. There's always a big debate about the role of agriculture in contributing to the hypoxic zone in the Gulf of Mexico versus point source pollution, factories, cities, etc. But regardless of where phosphorus comes from, we realize that in agriculture we have the opportunity to optimize or increase the efficiency of our nutrient applications to reduce our contribution to reduced water quality. And so the question becomes, how can agriculture actually reduce phosphorus losses and improve phosphorus use efficiency? We can think about reducing surface runoff. So that could include things like cover crops to reduce erosion outside of the growing season of the main crop. Potentially drainage water management to reduce the amount of soluble P that's leaving the field. Capturing phosphorus losses in maybe constructed wetlands or approaches like that. But maybe more importantly for this conversation, for our nutrient management, or selecting a source that enables a more efficient rate of phosphorus. Within potatoes, there's some unique factors that contribute to phosphorus use efficiency, and potatoes are widely considered to have low phosphorus use efficiency compared to other crops. And why is that? I think a lot of it has to come down to the rooting architecture, the root system of a potato crop, and that limitation on the fine roots compared to a crop like corn is an example that has a very dense, fine fibrous root system. The information on this slide is illustrating the fact that as we have a small or a low root length density, or fewer roots per cubic centimeter of soil, the amount of soil that that plant can explore to access phosphorus or potassium becomes quite limited. And so what does that mean for potatoes? I mean, often it means that we're banding higher rates of phosphorus, often in excess of what the soil test would recommend, because potatoes are more responsive to those inputs of phosphorus. The other factor that's widely understood to affect soil phosphorus availability is the influence of soil pH. High pH, phosphorus is being fixed by cations like calcium. Low pH, iron and aluminum, become more important. And in essence, what we do in the field is you either add lime if the soil pH is too low to try to bring it up to that more neutral 6.5 to 7 range, or if we're at higher pH values, it can be challenging to bring that pH down to a more optimal value to increase the availability of phosphorus to the crop, as well as other nutrients that may be limiting in the soil. All right, so thinking about2 nutrients and starter fertilizers, which are often very important or commonly used in potato production. For the last 2 years, ICL has been conducting trials on a product that we have, proprietary product called Agrolution pHLow 114511, which is a dry water soluble fertilizer, and comparing that to ammonium polyphosphate, or what's more commonly or widely recognized as 1034O, as a liquid source of a starter fertilizer. There's some key differences between these products, with one being a dry initially and having to be solubilized, one being a liquid. Agrolution pHLow has a low salt index. It's an orthophosphate based product versus ammonium polyphosphate, which is a higher salt index, and higher salt index a product as well. But we've been conducting trials on these to really understand if there's any benefit to using Agrolution pHLow as a starter fertilizer compared to something that's widely available like 1034O as a commodity fertilizer. So this is an example of 3 trials from this past year. One location in Wisconsin, which was Russet Burbank, and then the same geographical location in Michigan, but on 2 different varieties, Manistee and Russet North Dakota. Comparing a control with no starter fertilizer to ammonium polyphosphate, 1034O applied at 10 gallons per acre, and then Agrolution pHLow, the ICL product, at 10 pounds of dry product per acre that's then solubilized or put into solution and applied to the crop, like any other starter fertilizer. If we look at the Wisconsin location, we had lower yields compared to the 2 varieties planted in Michigan. Not much of a starter response in Wisconsin. We did have very large starter responses in Michigan, but also higher yields there as well. But if we simply look at this data, we would conclude that there was again no starter response at Wisconsin, and really no difference between the 2 starter fertilizer sources, 1034O and Agrolution pHLow, at the Michigan, the 2 Michigan trials, just based on the statistics. But the question that I want to pose is, does this data, and looking at the data this way, really tell the whole story, especially as we think about this question of sustainability and how we can improve efficiency of the system? So, the key thing to point out here is that 10 gallons per acre of 1034O is supplying about 40 pounds of P2O5 per acre, versus the Agrolution pHLow rate that we used, 10 pounds per acre, that's only supplying 4.5 pounds of P2O5 per acre. And so as we think about that previous slide, we were getting similar or numerically greater starter responses from Agrolution pHLow, but it's really only supplying about 1/10 the total phosphorus that a grower standard rate of 1034O would supply. So if we express that as phosphorus use efficiency for these 3 different locations, we can see that phosphorus use efficiency as 100 per pounds of P2O5 applied is quite low for 1034O, and is 13, 14, and 11 times more efficient for Agrolution pHLow, just because we were getting the same types of starter responses or greater starter responses with that much reduced rate of phosphorus. And there's much that we can say about this and have great discussion about the pH effect of Agrolution pHLow versus 1034O. But the take home point is that fertilizer choices, in this example, phosphorus fertilizer choices, can have huge impacts on phosphorus use efficiency and improve agricultural sustainability of the production system. So in conclusion, if it's not clear yet, fertility choices do matter. I think we all realize that from a yield and economic profitability standpoint, but fertility choices also matter in sustainable potato production. And looking at ways in which we can affect nitrogen use efficiency, phosphorus use efficiency, and nutrient use efficiency in general to improve water quality, soil quality, and air quality through the different pathways or routes in which nutrients are lost to the environment. As Georg highlighted at the beginning of this presentation, consumers and food companies are demanding more sustainability benefits from food products, and that will likely only increase over time. As we think about polysulphate as that first example, fertilizer production can definitely result in significant carbon emissions, but there are opportunities like polysulphate that are natural mineral sources that have a low carbon footprint and improve the efficiency of other nutrients like nitrogen through supplying sulfur, which is needed very much in a lot of cropping systems. Controlled release fertilizers, so those polymer or resin coated fertilizers, your urea products, are an effective tool for protecting against nitrogen losses and improving nitrogen use efficiency as a result. And then finally, with the example of 1034O and Agrolution pHLow as banded starter fertilizers, we can conclude that phosphorus source does matter to increase the efficiency and potentially reduce the need for high phosphorus application rates in crops like potatoes that are recognized as being very responsive to phosphorus or phosphorus intensive crops. So with that, on behalf of ICL North America, but also ICL globally, I'd like to thank you for your time this afternoon and joining us for this discussion about sustainability in potato production and why fertility choices matter. If you have any questions about things that we've covered today, we'll certainly have some time now to address those questions. But if you'd like to get in contact with us directly, my email address as well as George's is shown here on the screen, and would also invite you to visit our ICL Growing Solutions US website, where we have product information, but also trial information and a lot of thought leadership resources on agronomy that could be useful to you. Okay, well, thank you.
Thank you so much, Jason and Georg, for that fascinating discussion. A reminder, if you would like to ask a question, go ahead and put it in the Q&A box there at the bottom of your screen. Talking of controlled release fertilizer and its role in sustainability in particular, fertigation is, of course, a common practice in irrigated potato production. Is that with water obviously at a premium in terms of a natural resource, is that also a way, in addition to reducing nitrogen loss, a reason for growers to potentially consider controlled release fertilizer as a way to perhaps better control their water usage?
Well, I think that's a good question, and you're correct. There are many potato growing regions of North America, U.S. especially, where irrigation is commonly used. And with irrigation, comes the opportunity to fertigate with nitrogen. So, at first glance, controlled release fertilizers may be of less value, in those areas. But at the same time, I think controlled release fertilizers applied early in the season to the soil, provide that base foundation for nitrogen fertility. And then with the intensive use of petiole analysis in potatoes and fine tuning that nutrition through the growing season, there's always the opportunity to add more nitrogen if needed through the fertigation system. The other opportunity that I see for controlled release fertilizers in some irrigated potato production systems is that Michigan is an example. Potatoes can still be planted in the pivot corners that you're not necessarily receiving irrigation water, but still have some rainfall occurring, and controlled release fertilizers can be a complementary way to manage nitrogen in those corners that don't have the benefit of the fertigation being applied through the pivot.
All right, thank you. We touched a little on cover crops as part of this sort of ongoing definition of regenerative agriculture. Could either of you just expand a little on the role of cover crops in achieving sustainability in production, and what factors influence which crops growers should look at in that role?
Well, I certainly can answer, but George, would you like to maybe provide your perspective on cover crops and how those are viewed in the broader context of regenerative agriculture, and then I'll weigh in as well.
Yeah, absolutely. Yeah, so I think they've kind of become one of the, I want to say, staples of what regenerative agriculture programs look like globally. I know we've done a lot of work with them also in Europe, especially for grasslands. In that context with polysulphate actually very successfully, and that's been a really good experience. Yeah, but basically I think they've become one of the strongholds of what a regenerative agriculture program will look like. And we know also that for many of those leguminous crops that are often used, sulfur is a very important element to be used, which I think is something that you will probably pick up on, Jason, right?
Yeah, absolutely. Yeah, I guess my perspective on cover crops is that, just, first as some context, I'm based in Illinois. And so, I look out my window and see, bare fields, or, fields that are often bare for, 6 months, or, sometimes more throughout the year. And so when you see that, it definitely, at least reminds me that, it's important to have, living cover, in fields, because that's, how nature often intends it to capture nutrients, reduce erosion. You have those living plants to stimulate the microbial life in the soil, and so there's a lot of positives for using cover crops. But I think one of the challenges in agriculture, especially when we go immediately to the use of a cover crop, is that in some cases cover crops may not be practical based on geography, length of season, cropping system, et cetera. And so think about potatoes and having a full season, main crop potato, harvested late in the season, there's probably, very limited opportunity, or there may be no opportunity to get a cover crop planted and established, before winter sets in, to have a, positive benefit, on the cropping system. And so I think we have to, balance some of those, practical implications as well when we, recommend, cover crops as a foundation for sustainability or regenerative agriculture. But, to George's point, and going back to your question about cover crop selection, I think it really depends on what you're trying to achieve with a cover crop. Is it nutrient capture? Is it having a a very fibrous root system, or to reduce erosion? Is it using a tap-rooted crop to break up compaction? I mean, those are all possibilities. But we do know that oftentimes cover crops are legumes designed to fix nitrogen and add that to the soil. And with that, comes into the conversation of, specifically fertilizing those cover crops to maximize their nitrogen fixation and contribution to the soil. Sulfur is an important part of that. So I think that's a good way to, think about, sulfur source like polysulphate, applied at the same time as, planting the cover crop to get to that nutrition into the system, but also, nourish those cover crops for maximum productivity.
Right. Thanks for that information as well. In terms of the sort of overall larger picture of sustainability that we're talking about here, George had cited that study in the beginning with some of the numbers, 79% of consumers saying companies should take a role in protecting the environment, for example. I just wondered from an industry perspective if those numbers were sort of in line with what you've seen and heard, and also what are the driving factors behind turning that concern into a willingness to spend the money to see that desire become reality for sustainability?
Okay, let me start with the last part that you mentioned maybe first. So I mean, of course, aside from the consumer expectations that I think are continuously growing in terms of consumers expecting businesses to move in that direction. Of course, there's also, plenty of regulatory pressure that is building, especially on the European end, but I think also in the US now, there's been a really, really big push in that direction. And along those lines, also, I think something that gets overlooked often is that there's quite a bit of financial pressure for those businesses to move in that direction as well, in terms of, loans that they can secure against achieving certain goals, etc. So I think the momentum is so extremely strong in that direction. And also, of course, along with the regulatory changes, there are also many investment opportunities that are going in that direction. So, for example, if you're looking at where the research money from the Inflation Reduction Act is going, it's all going towards regenerative agriculture. In this case, I think it's $19.5 billion, for example, just in the US that are being spent in that direction. So I think the economic incentives are extremely obviously going just towards regenerative agriculture and a more sustainable agriculture.
Well, thank you for that, George. It's certainly a multifaceted issue with a lot of different avenues to consider. We greatly appreciate you giving us the tools to consider this particular avenue of sustainability today. We are going to bring up the QR code one more time for everyone to scan for their CEU credit. And again, we thank you very much, gentlemen, for your time this afternoon. And it will certainly be a discussion worth keeping tabs on going forward.
Thank you. It's been a pleasure.
Thank you, Melinda.
Thank you both. Have a great day.
Bye-bye.